68, Algebra 2, we're going to talk about finding conditional probability. Conditional probability is the probability, and if you're looking in your book, let's make sure that we're over here too. We're going to be doing 68 and 69. This starts off on page 483. Finding conditional probability. This is the probability. I'm sorry, like if I got a real scrunched up look on my face because I have to sneeze, but it's not there. Right? Do you ever get frustrated, like you got to sneeze at the end of your nose, but you can't? That's what I've got going on right now. The probability of two independent events is the product of their individual probabilities. However, finding the probability of two dependent events requires finding a conditional probability. And that's the probability of B divided by A, or the probability of B given that A has occurred is a conditional probability. I know this doesn't necessarily make sense right now, but my hope is that it'll make sense here after a little bit and we start looking at examples of what we're talking about by P, B, and A. Okay. Dependent events. If A and B are dependent events, then what we're going to do is we're going to find the probability of A and B. So like probability of A plus B is going to be equal to probability of A times the probability of B divided by A. Again, I know this doesn't make a lot of sense yet, but hopefully it will. So I'd be writing down, if nothing else, dependent events and then this formula here. Okay. I won't spend a lot of time just because this is in your book on page 483. You can find it there even if I scroll on and start talking about other events. In general, though, dependent events are a matter of the next event depends upon what happens with the first event. And when we talk about those, commonly it's like a word problem where if I had a deck of cards and I told Janet to take a card from the deck and I told her to keep the card. Right? She kept the card, and let's say it was a 3 of hearts. Right? The probability of her getting a 3 of hearts is an independent event because nothing else has happened before her. Right? She has a 1 in 52 chance of getting a 3 of hearts, correct? Okay. But if she keeps that card, and I come over to Emily, and I have her draw a card at random, her probability of getting, say, a 3 of diamonds is 1 out of 51. That second event is dependent upon what happened the first time, right? Okay? Those are dependent events. Now, if Janet had put the card back, she still would have had a 1 out of 52 chance because we're still having 52 cards. Remember what probability is. It's the number of desired over the number of total. Whenever she keeps the card, it changes the total, which means it changes the probability. Does that make sense? Okay. All right. And then we're also going to talk about lesson 69 kind of at the same time, just so that we're doing all of this together, and then we'll go back and we'll look at some questions. This is talking about simplifying complex expressions. We've already talked about I, right? I is the square root of -1. We've seen square root of negative numbers, and we're going to come back to that. Complex numbers we've seen in the form of A plus BI. These things can be graphed on a complex plane, where the horizontal axis represents the real part, or the A, and the vertical, that up and down movement, is represented by the imaginary part, which is B times I. All right? We see a visual of it here. The absolute value of A plus BI is equal to the square root of A squared plus B squared. Therefore, A is representing my X movement, B is representing my vertical movement, and my line or vector that I see here is representing that absolute value of A plus BI. Okay, that's what it'll look like when it's graphed. It'll make a right triangle with the x-axis. Okay. Now I want to talk to you a little bit about I. I to the first is I. This also equals, the square root of -1 is I. I squared is -1 because the square root of -1 times the square root of -1 is equal to -1. Okay? But then whenever we get to I cubed, right, we have square root of negative 1 times the square root of negative 1 times the square root of negative 1, right? Where all of these are I cubed, okay? Here I get negative 1 times negative 1, so that's negative 1 times the square root of negative 1, and this is the same as I, so it's like saying negative 1 times I, so I'm left with negative I. Okay, that's how I get negative I out of that. Okay, if I come down to I to the fourth, that's square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Well, the square root of negative 1 times the square root of negative 1 is negative 1. The square root of negative 1 times the square root of negative 1 is negative 1. What's negative 1 times negative 1? 1. Okay, you follow me so far? Am I going too fast? Okay. Okay. And then we should start to see a pattern with the rest of this. You see, by the time we get to negative 5, I to the fifth, it comes back and we're right back at 1 again. All right? So I want you to notice what happens with odd and even exponents. Okay? We said that I squared is negative 1, right? So let's think about it like this, if it helps. I've got 5 i's. These two i's together equal negative 1. Those two i's together equal negative 1. And that's just an I. That's 1. This is I. I'm left with just I. Does that make sense? Okay. We can show it again, I to the sixth. Okay. And I'm going to pair these i's up in groups of 2. Because this is negative 1 times negative 1 times negative 1. So that's 1 times negative 1, which gets me negative 1. Make sense? Okay, I to the seventh, 1, 2, 3, 4, 5, 6, 7. Okay, so I've got positive 1 times negative 1 is negative 1 times I gets me negative I. And we go all the way over here to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, well we know this is 1 and we know this is 1. So we get 1 out of that. Okay. So anytime I have a 4 as a factor of that number, then I'm going to get 1. Okay? If I have like an even number like 6, but 4 is not a factor of it, I'm going to get negative 1. And if I have an odd number, anytime I have an odd number, right? I got 1, I got 3, I got 5, I got 7. They're going to alternate between I and negative I. Okay? So when the remainder is 0, okay, we get like I to the fourth, there's a 0 remainder there. We get 1. When there's a 1 remainder, okay, we get I. When 2 is a remainder, you get negative 1. And when 3 is a remainder, you get negative I. Those are your 4 options for I. All right, and that's kind of the end of that. We're going to jump into our lesson here. I don't know that I actually have it pulled up. Let me do that. Okay, we are ready for lesson 68, 69. All right, let's look at this first one. Joe's got 11 markers in his backpack. One of them is dark brown, one is tan. We don't know what the other 9 are. It doesn't really matter. We want to find the probability that Joe will reach into the backpack. There it is. We got it out. All right, we want to find the probability that Joe will reach into his backpack without looking and grab the dark brown marker, then reach in the second time and grab the tan marker. Express your answer as a fraction in simplest form. So let's deal with one thing at a time. What is the probability that he can reach into his bag the very first time and grab the brown marker? 1 over 11. Good. All right, then after he's got his brown marker, he's going to reach in, he's going to grab that tan marker. What's our probability there? 1 over 10. All right, and we're going to simplify that, so we're going to get 1 over 110. Okay, the second event is dependent upon what happens with the first event. Does that make sense? We get D as an answer. Okay, you guys are pretty good there. All right, let's look over here at 2. I gotta get a drink. Bonnie and Kelly, a part of a group going to a basketball game. The group has 2 courtside seats, 2 lower level seats, 5 upper level seats. If the group randomly chooses their seats, what is the probability that both Bonnie and Kelly will sit courtside at the basketball game? Express your answer as a %. If necessary, round your answer to the nearest tenth. Okay, so we want a courtside seat, right? How many of those are there? 2. So my desired number is 2. How many seats are there? 9. Okay, so let's assume that's Bonnie's probability of getting a courtside seat, 2 and 9. But once Bonnie gets that seat, what's the probability of Kelly getting the other courtside seat? 1 over 8. Okay, so we're going to get 2 over what, 72? All right, what is that? 2 over 72. Somebody give that to me as a decimal. 0.2. 0.2 what? 7. What's after 7? 7. Okay, so we want to convert this over to %, right? We want our answer to the nearest tenth as a %, so we're going to move our decimal point over. All right, so we're going to, actually, it's not that far over. Was it 0.27 or was it 0.027? 0.277. All right, so we're going to move this over. What we're going to get is 2.8%, because we want to round that to the nearest tenth. Okay? Does this make sense so far? Good. All right, number 3. The table shows the distribution of the labor force in the United States in the year 2000. Suppose that a worker is selected at random. If the person selected is female, okay, what is the probability that she works in the industry field? Okay, express your answer as a decimal to the nearest 1,000. All right, so we're going to take industry, right, which is the selection. That's what we want, right? That's our desired, and we're going to put it over the total. So what numbers do I have to add up? Am I adding all of the numbers? No, we're only adding what numbers? The female numbers, right? We're only adding the female numbers. So we're going to add the 667,000, 8,004,000, 57,362,000. On top is going to be our 8,004,000. All right, can we tell me, and hopefully you're doing some adding here, what 667,000 plus 8,004,000 plus 57,362,000 is? Well, for sake of time, I'm going to tell you. All right, we should get 660. Somebody check my answer here, make sure I'm right. 33000. Is that right? All right, so 66,033,000. All right, so we want to take 8,004,000. We want to divide it by 66,033,000. And we're going to express our answer as a decimal to the nearest 1,000, so we need to take it to 3 decimal places. 0.121. All right, doable, right? Bigger numbers, but we can do that. So far, this end of it's pretty easy. All right, let's drop it down here. This says graph -2i, and if you remember, we're looking for a A plus BI, where A is my left and right movement, B is my up and down movement, right? Do I have any left or right movement in negative 2i? No, because essentially what this is 0 minus 2i. I'm not going anywhere left or right, but where am I going instead? Where am I going up and down? If I'm not going left or right, because I don't have an A, what is my B? Negative 2, right? So I'm going to go from the origin where? Down how far? 2. So A is actually my answer, right? Here they went 2 up, right? I know there's an absolute value sign, but it's not changing the actual value of where we're going, okay? So A is our answer. 0 minus 2i is graphed as A. Oh, hold on. What? I got 2 different. Oh, okay, because it's weird how it's on my paper. Okay. So let's see. So here it's got, and this is what's funky. Here's 4A and B, but 4C and D are right here. I don't know if you can see my cursor. Hopefully you can. But for the next question, 5 goes A, B, C, and D. Okay? So looking at this 4 plus 2i from the origin, how...
Pardon the interruption, just a brief announcement. 7th and 8th grade students, do not forget that your Missouri Western State University field trip permission slips are due today. You will need to have those in the office today. You do not need any money today. That will be brought with you for lunch on field trip day. Also, junior high track practice is not going to happen today, but will be tomorrow. Please make sure to dress warmly tomorrow, as you will need it. You will be outside for junior high track practice tomorrow. Thank you.
All right, am I going left or right in 4 plus 2i? Right, how far? 4. So I'm going to go 4 to the right. Am I going up or down? Up how far? 2. So I should get something that puts a dot right there. All right, do I have anything that does that? A, B, C, or D? Now remember, it goes A.
Pardon the interruption again. I apologize. The Missouri Western State University field trip permission slips for 7th and 8th graders. Those are due tomorrow. Again, we do not need your money. We'll bring that the day up for lunch on campus. But we do need to sign permission slips no later than tomorrow. Thank you.
Okay, I'm just going to tell you, the answer is B. The answer is B. Okay? All right. 6. Find the absolute value of negative 7 minus 9i. Negative 7 minus 9i. So what we want to remember about this, as we saw this in an earlier page, is that this is equal to, if I have a plus bi, that this is equal to a squared plus b squared, right? Yes? Remember that? All right, so what we're changing this to is negative 7 squared plus negative 9 squared. All right, so negative 7 squared is what? 49, okay? And negative 9 squared is 81. Okay, so what is 49 plus 81? All right, so we're at square root of 130. And if we could reduce that, we would. Unfortunately, and again, unfortunately for all the announcements, I can't go through all the reasons why. But basically, if we try to bring 130 down, right, you're going to divide that by 10. You could divide it by 10 and get 13. 13 doesn't reduce, and 10 comes down to 2 and 5. So I don't have 2 of anything that comes out of 130. So it's just square root of 130. Okay? 7. This is 6i times 4 minus 6i. So this is just a simple distribution. So 6i times 4 is going to be 24i. We agree with that? All right, but 6i times negative 6i is negative 36 I squared. But what is I squared? Negative 1, right? So that's negative 36 times negative 1. What's negative 36 times negative 1? Positive 36. And because we want this in a plus bi form, we're going to put 36 plus 24i. All right, so we get b right there. All right, does that make sense? We see how we get there? Yes, hopefully, maybe. All right. All right, let's see, that was 7. Let's go to 8. Negative 8i to the 20th. So let's do the I to the 20th part. Is 20 divisible by 4? Yes, because 20 is divisible by 4 with 0 remainder, it equals 1, right? So what we're actually getting here is negative 8 times 1, which is negative 8. Okay? Does that make sense? Okay? All right, great. All right, number 9. All right, this one we want in a plus bi form as well. Negative 2 plus 2i over 5 plus 3i. All right, this one, they actually didn't go into this in this lesson. But because it's a complex denominator, we're going to multiply the top and bottom by the conjugate of the denominator. We've done this with square roots, right? Where I had radicals in the denominator. Do we remember doing something? All right, so what we're going to do here is 5 minus 3i, 5 minus 3i. And then we're going to FOIL. All right, does that at least ring a bell on how to do that? Okay? So looking across the top, we've got negative 2 times 5 is negative 10. We've got negative 2 times negative 3i, which is positive 6i. We have 2 times 5i, which is 10i. And we have 2i times negative 3i. This is where it gets complicated. Because 2 times negative 3 is negative 6, right? All right? But I times I is I squared, and I squared is negative 1. So what we're getting is negative 6 times negative 1. So what is that answer? Positive 6. So as we finish this out, I'm going to combine like terms. Negative 10 plus 6 is negative 4 plus 16i. Does that make sense on how we got the numerator? Okay? All right, I know there's a lot there. Then, but all I have to worry across the bottom is because it's a sum difference is just the outer two terms. So we got 25, and then we have the same situation with 3 times negative 3i. 3 times negative 3 is negative 9, but I times I is I squared, which is, so negative 9 times negative 1 is positive 9, right? So we wind up with 25 plus 9, which is 34, okay? So we get something that looks like this, but we can reduce all of this, right? We can divide everything in here. I don't know, let's see, does 34 divide by 4? Probably not, right? But everything will divide by 2, correct? Does 34 divide by 4? For whatever reason, I'm drawing a blank on that. I think it's just 32. All right, so negative 4 divided by 34, that's negative 2 over 17 plus, let's see, we can divide, that's going to be 8i over 17. Right, so you're seeing this right here as an answer. Okay, you follow me? All right. I think what will probably happen is that I'm going to stop here for this video, and what I'm going to do is I'm going to do the last, I'm going to do 10 through 15 with the other class. I'm going to record that. I'm going to send both videos to you guys. The assignment will still be due tomorrow. I really do believe that we covered enough material that even if I didn't do the next 5 or 6 questions, you guys would still be good to go, okay? So we're going to stop there, and I'll see you back in part 2.